Okay, rational expression. So yesterday we talked about polynomials. Polynomials have a positive exponent. Rational expression is where you have a polynomial on top and on bottom. So here's some examples. The way I always know, the easy way to identify a rational expression is that when you have a variable on the bottom, but technically, like even a fraction is just a rational expression, or if it doesn't have a variable on the bottom. So that's just identifying them. The domain, we've talked about domain before, but domain is all your x numbers, all the x values that it can be. So on this example right here, if you're trying to figure out what numbers x can be, the easiest thing to do is figure out what x can't be, and then say it can be everything else. So like right here, they kind of tell us the answer down here, but if I plugged in a 3, I'd get a 0 in the denominator, and you can't divide by 0. So the way that we solve these is that we are going to set the denominator equal to 0. And on these, we're just trying to figure out the ones that are not in the domain. So we want to figure out what numbers make the denominator go to 0. It's like the first one's pretty easy. You just do x minus 5 equals 0. Add 5 to both sides. That's the one number it can't be. If I plugged a 5 into that function, I would get a 0 in the denominator, and I cannot divide by 0. One thing good about this lesson right after yesterday's is that it does have a good refresher over everything that we did yesterday. So the next one, B, x squared minus 49 equals 0. I set the denominator equal to 0. Hopefully you're starting to recognize that. But x squared minus 49, that is a perfect square. It's two terms. You got an x squared, so you're thinking factoring. So it's going to break down and look like this. You got x times x is x squared. 7 times 7 is 49, and a plus and a minus. And then you set both of those equal to 0. And you subtract 7 from both sides and add 7 to both sides. So that is my answer. It's positive 7 and negative 7. Those are the two numbers that x can't be, really. If I plugged in a negative 7 or a 7 in there, I would end up with a 0 in the denominator, which means it doesn't work because you cannot divide by 0. And then the last one, another good refresher over what we were doing yesterday. When you set that denominator equal to 0, you're looking at, okay, what multiplies to be negative 14 and adds up to be negative 5. That'll be what, negative 7, positive 2. So x times x is x squared. Negative 7 times 2 is negative 14. Negative 7 plus 2 would be negative 5. And then you set both of those equal to 0. And you add 7 and subtract 2. Again, those are the two numbers that x can't be. Because if I plug those in, I'd get a 0 in the denominator, and you cannot divide by 0. Okay, this is way back to like the first day of class. But on the first day of class, I gave you like a fraction, or there was a fraction. And, to reduce this fraction, what y'all would do, you just divide both sides by 5. That's the way we think about it. But I wrote this out because what you're actually doing when you divide by 5 is you're breaking it down to the factors. And you're saying, okay, there's a 5 on top and a 5 on bottom. They cancel out. So the answer is 3/4. So this is how you actually simplify these rational expressions, is you're going to break down the top, you're going to break down the bottom, and see what cancels out. So there's a couple different thought processes with that, but this is basically what's going to happen all throughout today, is you break down the top, the bottom, and then see what cancels out. All right. So the first one right here, there are 3 different terms in here. Okay, this kind of confuses people, but there are 3 different terms in this problem. The way I think about this one, you can't really simplify the top. You could simplify the bottom, but it looks more confusing to me that way. So I'm going to do it this way because this comes in handy next week or the week after too. 3 terms. To divide something out of, those something like this, you have to be able to divide it out of every term that's in there, okay? So since I have 3 terms and they're all divisible by 2, I can divide those all by 2. Okay, so what I would do here, do not just do this, because 2x is being divided by 2x minus 12. So you can't just cross those out. But you can just divide all of those by 2 because every term in it has the same letter there. The way you do the other way is if you simplify the bottom, and I just don't want this to confuse you. Here you can cancel out the 2's because the 2 is being multiplied to both of those. I didn't even want you to look at that. I don't like that because then you're going to think you can just cancel out the 2's, and you can't. All 3 terms have a 2 in it, so you can divide everything by 2. The next one's you can't simplify, or it already is simplified. I don't know how Alex says that. But you have 2u plus 7 and then 7u plus 2. It's just making sure that you don't do anything like this. You can't do that. Here you have 4 terms, 1, 2, 3, 4, and all 4 of those have to be divisible by the same thing. C, you need to rewrite this one, and you could rewrite it as, I'm going to put the v first. The v is positive, and the 2 is negative. And now you can easily see that you can simplify that. When you have something divided by itself, anything divided by itself is 1. And that would just be my answer. The next one, D, looks like you should be able to simplify it. So they just got different signs. So what if I factored out a negative 1 on top? That'd give me positive u and positive 5. And then I have u plus 5 on the bottom. So if you have a u plus 5 on top and a u plus 5 on the bottom, they're the same. I can factor those out and simplify those. The last one I'm going to rewrite real quick just so I can... So on this one, you want to look at the numbers, then the W's, then the W's plus 4's, and just go through each one individually. I'm actually going to write my answer up here. So 32 over 40, you could divide both those by 8, right? So it would be 4 over 5. Sorry, I'm going to blank there for a second. 4 over 5. And then my W's, you got 4 W's on top and 3 on the bottom, so you got an extra W on top. That W plus 4, I've got 2 of these on top and then 5 of them on the bottom. So it's the same thing, even though we got like more. I got 2 of these on top and 5 of these on top or on bottom, so I've got 3 extra of them on the bottom. So you work that the same way. You just kind of do 2 of those on top, 5 on the bottom. You got 3 extra on the bottom. And then that 3W plus 2, there's nothing you can cancel out with that. So that is my answer. I've simplified that as much as I can. So you're going to do this like we did way back in Exponent World. You can just go through each one and do the numbers, do the X's, do the Y's, do all the similar ones, and look for anything that cancels out. Yeah, we will go ahead and do these because all right, so what you want to do on something like this is you want to simplify the top and then simplify the bottom and then go from there. So for my top, I'm going to rewrite it real quick with the X first because it's just easier to look at. What's your number one step of factoring? And again, rewriting it just so we walk through this. You got negative 5x squared here. This is a positive 20, so you write plus 20. Okay. Number one step of factoring, what was it? Anybody? What? You're right there. Yeah, GCF. The GCF. So I factor out the GCF here. You really don't want that first term to be negative, so I'm going to factor out a -5. And it becomes positive x squared, and 20 divided by -5 would be -4. And once again, hopefully this is looking familiar to you when you see like an x squared minus 4. X times x is x squared. 2 times 2 is 4. And a plus and a minus. So that's the top. And then the bottom, what are we doing on the bottom? We're looking at what multiplies to be -12 and adds up to be 4. Usually if you get stuck, by the way, it's going to be one of these, so something cancels out. That kind of helps you. Should be what? +6 minus 2. So x times x is x squared. 6 times -2 is -12. 6 plus -2 would be 4. Now, just to clarify too, the reason that I went to this thing where I'm saying what multiplies to be the last number and adds up to be the middle number on this one was because there are 3 terms here. The x squared, the 4x, and the -12. The reason I just went straight into this with this one was because there's 2 terms there. And I know the square root of 4 is a perfect square. The square root of 4 is 2. So when it's 2 terms, it's going to be one of the special ones, and you should do it quick. All right, so these cancel out. Whoops. And I get -5, x plus 2 on top. And on the bottom, I get x plus 6. And we do usually just leave our answer like this. You do not have to distribute the -5 through. Wouldn't count it wrong on the test. Alex wouldn't count it wrong. But this is called factored form, so it makes some of the next steps that you would do with this, if you're going on to college algebra or pre-calculus or something and looking at the graphs of it, it's easier just to leave it in this form right here. So you do not have to distribute it back through. All right, next one. I guess this is very, very similar to the one we just did. Let's skip this one because we're going to do this like a million times today. So, all right, we'll skip G. 3, I'm not going to really do. I'll just talk about it real quick, so I wouldn't write any of this down. This one's just showing you that you can't simplify like wrongly, like some different ways. So like I can't just cross out these 3s. Because remember, all 4 terms have to be divisible by something. Okay, so that does not work. That's bad. This one actually does work, I think. So if I factor out a 4, or you could do what I did earlier, right? All of these are divisible by 4. All of those are divisible by 4. So that would leave me with x minus 2. Okay, so that one would work. This one's good. This one, they just cross out the 2. You cannot do that, because you still have 7 divided by 2. 7's also being divided by 2. And this one, I don't even know what they did. They didn't just cross these out. They made it 1. So they did like 8x divided by 8x is 1. But then you still have 3 divided by 8x. You can't do that. Okay, so all you have to do, the only thing you can do is when you use all 3 terms are divisible by something. But we'll keep saying that. All right. Next part. We can just look right here. They have these like fraction examples because these work just like fractions. You don't have to write this down. But when you multiply fractions, remember I just drew the line right there and then you multiplied straight across. A times C and B times D. When you divide fractions, what do? What's the words we use? Keep, change, flip. Keep, change, flip, okay? Same thing. So anytime you forget what to do on these are just big, scary looking fractions. They're not anything different. You're still going to use the same thought process. I don't really like doing this one, but I'll do it anyways. So when you multiply, you just multiply straight across. Now, the reason I don't like doing this is because you could multiply and then simplify. If you remember, we did this with fractions too, but you could simplify, then multiply. On fractions, I simplified, then multiply, and it kind of goes better with this if we simplify first and then multiply. So we're going to try to do it. I did it the other way in the class. You can do 12 divided by 4 would be 3 and 1, right? Okay. Let's see what else we got. Okay. So on the top, if I look at my numbers, I got 9. My y's are easy. Let's do my y's first. I got 3 on top and 2 on the bottom, right? 3 on top, 2 on the bottom, so that leaves me with 1 extra y on top. My x's, how many x's do I have on top? I got 2, right? So I got 2 x's on top and 5 on the bottom, so that leaves me with 3 extra on the bottom. Okay. So that's one way you can do it. The other way, you could just go ahead and multiply, like make it 3x squared y cubed, 36, 12 times 3 is 36, and then 4x to the 5 y squared, and just go through the process there if you want to multiply and then simplify. So we kind of simplified and then multiplied, but you can multiply and then simplify too. But that's not like the one on your test, and that's not really what you'll do much with these. That's more of like the old stuff. What you are going to do is something that looks more like this. Where it has, you have 4 different things to do, okay? Tell me if you can't see any of these colors. But you are going to look at the upper left, the upper right, the bottom left, the bottom right. So my upper left one here, I'm going to divide by 5. Oh, GCF, right? Sorry, I didn't say it. But just the upper left, that 25x plus 10. So that's why I highlighted it, 25x plus 10. You can factor out a 5, so that leaves me with 5x plus 2. Okay? My upper right, I can divide by 3. So that leaves me with x minus 8. What's next? Bottom left. Looks like I could factor out a 6. And that'd leave me with x minus 8. And then the bottom right, hopefully y'all can see that yellow. If you can't, let me know. 5x plus 2, I can't do anything, so I'm just going to rewrite it. Okay? When you do this, hopefully at least something cancels out. 5x plus 2, 5x plus 2, x minus 8, x minus 8. You could also go ahead and do the 3 and 6, right? That would be 1 and that would be 2. So that all big fractions, when you multiply them, comes out to be just 5 halves. Not everything's going to cancel out every time like that, but at least one thing. I feel like there's one of these weird ones on the test, and when you do the test and it's a big one, and only one thing cancels out. But at least one thing should cancel out every time when you do that. It's not guaranteed, but should. I don't think I'm going to do that one. All right, next one, same idea. Upper left. I could factor out a 5 again. So that's x plus 5. Upper right is red. Can't do anything with that, can I? 7x and 3, 7 and 3. So I just rewrite it. Bottom left. What's my bottom left become? Anybody? You got an x squared, so you're thinking factoring. I can't really pull out a GCF between 49 and 9, but there's 2 terms. Do you know the square root of those terms? 7 and 3. So 7x times 7x is 49x squared. 3 times 3 is 9, and a plus and a minus. And then bottom right, it doesn't look like I can simplify. So on this one, there's only 2 things you can cross out. So I have 5 x plus 5 over 7x minus 3, 3x minus 2. So the simplification, you got to simplify the upper left, the upper right, the bottom left, the bottom right, and then start crossing stuff out. Okay, E. What I would do with E is as soon as you see this division sign, I'd almost write on your paper, flip. I actually believe the one on your test is just, I don't even think you have a multiplication one. I think you got a division and a subtraction one. So you want to flip this, okay? Now, I'm not going to rewrite the whole thing because it's just a lot of writing. I'm just going to start my process, and I'll show you how to make it not so much writing. All right, upper left. Upper left, that's a 3-term one, so I'm saying what multiplies to be 2 and adds up to be 3? Two and 1. 2 times 1 is 2. 2 plus 1 is 3. So x times x is x squared, and a 2 and a 1. All right, now here's where you got to pay attention. I'm flipping the next one. So my upper right is actually this one right here. Right? That makes sense to everybody? If I flip that last one, that goes to the top. So I factor out a 4 and get x minus 3. And I've done this, color-coded this too, so it's always upper left is blue, upper right is red. Next one, bottom left, x minus 3, I just got to rewrite that. And then bottom right is going to be the top one over here. So if I GCF a 3 out of that, I get x squared minus 4. Hopefully, I think we've done the same one several times now, but so plus 2 minus 2. X times x is x squared. 2 times negative 2 is negative 4. The terms in the middle would cancel out if you're foiling it back out. Now, what do I got? X minus 3, x minus 3, x plus 2, x plus 2. So my answer is there's still a 4 up there and x plus 1. There's a 3 down here with an x minus 2. Do I want to do F? No, I want to do G. F's pretty similar to that one we just did. I guess you got 2 factoring ones, but. All right, G is a harder factoring one, but again, as soon as I see that division sign, I'm thinking keep, change, flip, okay? I don't want to have to rewrite this every time because it's a long problem to rewrite. I'll give you all a second to write it. I forgot about that, but give you all a second to write this. I don't want to have to rewrite it as keep, change, flip. Of course, if you need to, do it. Like, take the extra time to do it. But if I just put a note on my paper to flip it, then I can kind of flip it as I'm doing the next step. All right, my upper left has a trinomial. That means, and it's got a number in front of x squared this time. So remember, I had to do 5 times 2. What multiplies to be 10 and adds up to be 11? 10 and 1. So when I go over here, what do I have to write at the beginning of both of these? See how well you paid attention yesterday. I'm going to write 5x at the beginning of both of them, and then put my 10 and my 1. So now I can divide this one by 5, and I get x plus 2 and 5x plus 1. All right, upper right. Oh, man. Why did that go so small? Whoa. What in the world's happening? X plus 3. Okay, bottom left. Looks like I could factor out a 5. Bottom right would be this one. Okay, remember you flip them. On that one, I've got to do the multiplication thing again. So 3 times negative 7. So what multiplies to be negative 21 and adds up to be negative 20. What is it? Negative 21 and positive 1. So I write 3x at the beginning of both of them. And then I write a negative 21 and a positive 1. This one I can divide by 3, so I get x minus 7 and 3x plus 1. Pretty sure this is the one that makes me mad. There's only one thing that cancels out, and that's the x plus 3. I wish more than one thing canceled out on this. All right, adding and subtracting fractions. So if I'm adding or subtracting fractions, remember our steps here that we did last time, or when we did this a long time ago. We came up with the LCD. Should be 15 on this one. We can write some steps down here. It's not the greatest idea here, but the LCD. And then the second step is that you, how do I say this quickly? I'm going to say this because it works. Multiply by what's missing. I'm going to multiply by what's missing. So what I mean by that is, how do I go from 3 to 15? I multiply by 5, so then I need to multiply the top by 5. So that's called an equivalence fractions. Like 10/15 is the same thing as 2/3. Same thing over here. I'd multiply 5 times 3 to get 15, so I got to multiply the top. And then my answer would be 22 over 15. So when I add, what was I going to write? You add or subtract the numerators. You do not change, add or subtract the numerators. Okay? You do not change the denominator. It's kind of the 3 steps of adding and subtracting fractions. Well, the same steps are going to be with the rational expression. We're going to find the LCD. We're going to multiply by what's missing. And then you add or subtract the numerators. Okay, the other thing I was going to say, I think I can write it right here. Remember how greatest common factor was? Greatest common factor is the biggest number that you can divide them evenly into them. And you always take the biggest exponent to find that. No, I'm sorry, you take the smallest exponent. You take the smallest exponent. LCD is the exact opposite. You're going to take the smallest number you can multiply them to be. Okay, so greatest common factor is the biggest number that you can divide evenly into them, and the LCD is the smallest number that you can multiply them to be. And to keep in the opposite theme, you actually take the biggest exponent. Okay. I'll kind of show you how to find the LCD, or a trick maybe. So on this one, the LCD of the numbers, if you get stuck, like 20 and 8, not the easiest, you take the biggest number times 1. Does 8 go into that? No. Biggest number times 2. Does 8 go into that? Yes. So my exponent, or my number, is going to be 40. You just take the biggest number times 1, take it times 2, take it times 3, and see if the smaller number goes into that. And then the exponent, you just take the biggest one. So my LCD of that one would be 40x squared. Next one, my LCD of the numbers is going to be 16. Zoom in a little bit here. Because 8 and 16, the smallest numbers of those both multiply to be quickly would be 16. Like I can multiply 16 by 1 to get to 16. I multiply 8 by 2 to get 16, right? And then with the exponents, you take all of them, okay? You want all the exponents. So I need 8 x's, I need 6 v's, and I need 7 u's. So even though there's not x's over here, I need it. I need all the ones they have. So I'm going to take the biggest exponent from each one. So 8 x's, there's 6 v's and 5 v's, I take 6. There's 4 u's and there's 7 u's, so I take 7. You take the biggest exponent. The next one, my number is going to be 20. My x's, I got 2 over here on the left and 4 on the right. So I take all 8. My u's, I got 5 on the left and 1 on the right. So I take all 5. My y's, I got 7 on the left and 0 on the right. So I take all 7. Your test is going to be like one of these two, but I'll go ahead and do the next two just quickly. On the next one, you have an x and you have an x cubed. So I take x cubed. I've got 2 of these and then 1 of these over here, so I take 2 of them. And then I got 1 of these over here. I got 0 of them over here. That's fine. I'm still going to take 1 of them. And then part E, technically what you would need to do is factor these first. Y'all can factor the left one quick. The one on the right y'all might be getting pretty good at. What multiplies to be 10 and adds up to be -7, be -5 and -2. So what you do for this one is you take what they share and just write it once, but then you still write everything else in there. So the ones that they share, you only got to write once. The other ones, you still got to put them in there. So that's what my LCD would be. And I don't think we really have any like that. Okay, this one is kind of going, so we did step 1. Step 1's finding the LCD. Step 2 is you multiply by what's missing. So this one's just asking you to do that. 5 times 7 would be 35, so you multiply the top by 35. This keeps an equivalent fraction. An equivalent fraction means they are the same thing. One's just reduced, one's not. But if I had, I don't know, a piece of pizza and cut it into 5 slices, I gave you 4 of them. It'd be the same thing as if I cut it into 35 slices and gave you 28 of them. You'd have the same amount of pizza. On the next one, how do I go from 4x to the 8th to 12x to the 9th? I'm missing 4 times 3 would be 12, right? And then I'm missing an x. So if I multiply the bottom by 3x, I need to multiply the top by 3x. On C, how do I go from 2x plus 5 to this? 3x, somebody says. I think I agree. 3x times 2x would be 6x squared. 3x times 5 would be 15x. So if I multiply the bottom by 3x, I need to multiply the top by 3x. And then the one just below that, I need to multiply by y minus 9 to make it match that side. So I multiply the top by y minus 9. And again, you do not have to multiply those out most of the time. Sometimes you do, but... Well, I think one of the ones will work in just a second. You kind of have to multiply them out. All right, we're going to work a couple of these. I think like 3 of them, then probably call it a day. Okay, the very first one really annoys me, but the first one, the denominators are the same. X squared plus 6x plus 5, x squared plus 6x plus 5. This one is just showing you it doesn't matter how crazy the denominator gets. If the denominator stays the same, it stays the same. You don't have to do all this LCD stuff. But what I do want you to be careful of, and we got to be careful of this a lot on these problems, is the subtraction of the numerator. If you subtract the numerator, what you're technically doing, remember, is distributing that 1. So it's like negative x plus 6. And then combine like terms. That's the easiest way to do that, is to like distribute that 1 and do that. Because if you don't, what you end up doing is you have to go, I guess I go with my pencil. You'd have to do x squared minus 0, because there's not an x squared. Negative 6x minus x. But here's the tricky part. You'd have to do 0 minus a negative 6, because there's not a number over here. So the easiest thing to do is distribute that negative 1 through, and then you can combine like terms and make it x squared minus 7x plus 6. And technically what you should do, this is the one that makes me mad, I think, is you should factor these to see if anything cancels out. What multiplies to be 6 and adds up to be negative 7? Six and 1 add up to be 7, right? Negatives. Negative 6 times negative 1 is positive 6. Negative 6 plus negative 1 would be negative 7. And the other one is very similar because it's 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. And nothing cancels out. That's why that one makes me mad, because technically you got to factor to see if something cancels out, but nothing does. So that's your answer. Either one of those answers would work. I don't think you'll have too many like that, though. All right, B. What is my LCD on B? 12y. So I need this bottom to become 12y and this bottom to become 12y. Okay, so I'm going to multiply this by 3, right, to make it be 12y. So let's multiply this by 3. Here, I'm going to go ahead and distribute this out, mostly just because it's a number. It doesn't have an x or anything with it. But also because I haven't done the subtraction yet, so you might as well distribute it out. The next one, to go from 3y to 4, or 3y to 12y, I'm going to multiply by 4. So now I have 8y plus 12 when I distribute that through. Now, once again, what I would do is go ahead and distribute that negative through all of this. Does that make sense to do it like that? In your brains, that's the way I would rewrite it, almost with the redistributed. Rewrite the first one like it is and distribute that negative through. Because it gets hard with signs. If you don't have to, you don't have to. That's fine. Like you could do in your head on this one, 12y minus 8y, and then 9 minus 12, and it's not going to mess with you that much. When you got to start throwing zeros in there because the other one doesn't have an x or an x squared or something like that, it gets tricky. So just take 2 seconds to rewrite the second one with the opposite signs. Distribute a -1 through the second one. Then it makes it real easy. You got 4y minus 3. And that one hurt my brain earlier today. It really looks like you should be able to simplify it, but you can't because 1, 2, 3 terms. You would think that you could divide all 3 of those terms by the same number, but you can't, right? They just kind of all match. You can't divide them all by the same thing. So that is my answer. And the last one here, this one is like the one on your test, so I definitely want to do it today, so we can do it today and Monday and Tuesday. So we can do it a bunch of times before your test. LCD of this one. LCD of 8 and 6 would be 24. I've got 2 x's on the left, 1 on the right, so I do x squared. 1y on the left, 3 on the right, so I do y cubed. So I need my denominator to be 24x squared y cubed on both of them. So what can I multiply this one by to get it to be 24x squared y cubed? You got 3 x's, I already have 2 of them, and I need 2y squared, or 2 y's, y squared. So now I'm going to multiply the top by 3y squared, so that would be negative 27y squared. On the bottom one, what do I need? 4 and an x. Is that all good to you? 4 times 6 is 24. X times x is x squared. I already got y cubed, so I multiply the top by 4x. And I get 28x. Now I subtract. I cannot combine any like terms. Can't combine any like terms because one has an x and one has a y. And I really want to be able to simplify this one too, but I can't, right? This one's by 3, this one's by 3, this one's by 4, this one's by 4, but all 3 of them don't have the same. So that would be my answer.